All right, guys, welcome to this page of the notes. What we're going to do here is we're going to go ahead and start working on solving now a system of three equations. A couple of things before we jump into this. Just like with systems of two equations, we have two methods. We can do substitution or we can do elimination. And just like systems of two equations, there will be most of the time we're going to do elimination, but there were specific circumstances under which substitution turned out to be a better option. The same is going to be true for systems of three equations. Most of the time we'll use elimination, but there is a circumstance where substitution isn't necessarily better. Elimination will still work, but substitution is going to be faster. And since we want to work smarter, not harder, let's figure out when that is. And it turns out to be this first example problem that I've given you. So the first note that I made for you is this. When the equations have two or fewer variables, so here's what I mean by that. The first equation has an x and a y, but there's no z. And the second equation has a y and a z, but there's no x. That's what I mean. When you have equations that have two or fewer variables, it's missing. It doesn't have all three. It's missing somebody. Substitution. Substitution is going to be, and again, I put the best method. It's not necessarily best. It's going to be faster, right? We want to save time. So we're going to go with substitution to solve this particular problem. And then the second note is, okay, I got three variables. How do I know which one to solve for first? Well, that's the second note. You're going to solve for the variable that appears in each equation. That's the one that you're going to solve for first. So I take a look at the three equations I've got, and it looks like I got a y in this one, and a y in this one, and a y in this one, and that's the only variable that appears in all three equations. So for this problem, we're actually going to start by solving for y. The first variable we're going to find the value of is going to be y. Okay, let's jump into it. Remember, the way that you want to start these problems, just to help yourself keep track of where you're at, I would number them 1, 2, and 3. And then the next thing I would do is, again, along the way, just to help you not to get lost, but also to help you in case you do get lost, I make little notes. Just make yourself a little note to remind yourself what it was you were trying to do. That way, if you get lost, you can go back to that note. Oh, that's right, that's what I was trying, and pick up kind of where you left off. So let's do that. Here's what we're going to do. The equations that only have two variables in them. The idea here is this. If I can get this third equation, so that it only has y's in it, right? So that it only has y, right? I got an x here and a z here. If I can get rid of that x and that z and replace it with y's, well, then I can solve this equation for y by simplifying and combining like terms. Well, here's how we're going to do that. I'm going to take the first equation, which has an x and a y in it. I'm going to solve this first equation for x. What that's going to do is that's going to give me x equals something with a y in it. Substitute that in. I'll solve this equation that has a y and a z in it. I'll solve it for z. That means I'll have z equals something with a y. Substitute that in for z, and now I have an equation with nothing but y's in it. And substitution has greatly shortened the length of this problem. Here's how it's going to look. I'm making myself little notes. We are going to solve. We're going to solve, let me step over here. We're going to solve equation. Let me abbreviate equation so I don't run out of space. Solve equation number 1 for x. All right, here we go. I've got 2x plus y is equal to 3. 2x plus y is equal to 3. Okay, so now I need to solve for x. So we'll subtract the y to the other side, which means I have 3 minus y. Divide by 2, x is equal to 3 minus y, all divided by 2. I just found a new equation, so what we want to do is number that equation. This will be equation number 4. Okay, next we're going to solve equation number 2. We're going to solve for z. And again, please don't get confused here. I know I said solve for the variable that appears in each equation first. And you say, wait a second, I thought we were solving for y. We are. But what I need to be able to do in order to solve for y is I need to be able to do a substitution. So what I've now done, right, is I have something I can substitute for x. I know 3 minus y divided by 2 is x. So I'm going to plug that in for x, the substitution. I'm going to solve for z, right? And I'm going to plug that in for z. And what I'll have is an equation that has all y's in it, and I can then solve for y, okay? So I am solving for y, but in order to solve for y, I got to do substitution. And that's what we're trying to get to. My equation number 2 is y minus z is equal to 2, which means that negative z is equal to a minus y plus 2. Z is going to be equal to y minus 2. All right, I just found a new equation. That's going to be equation number 5. Okay, so here we go. Now that I have solved my 2 smaller equations, and I have something in terms of y, here we go. I am now going to, my next note, we are now going to substitute equation number 4 and number 5 into equation number 3. So I'm going to take the 2 equations I just found, 4 and 5, and I'm going to do this, right, substitution, right? That's substitution. That's going to be the fastest way to do it. I'm going to substitute 4, put that in for x. I'm going to substitute 5, I'll put that in for z, and I'll have this brand new equation. Here's what it's going to look like. When I plug this 3 minus y over 2 in for x, I would have 3. Nope, sorry, hold up, that's my highlighter, I apologize. Here we go. I will have 3 minus y. Hang on, I am standing in the way. 1 second, let me slide this over for you. I'll put it over here. I will have 3 minus y all divided by 2. That is my new x. Plus 2y. Plus 2y, because I got the 2y. Now I have the z, but I know what z is equal to. It's equal to y minus 2. So plus a y minus 2. And that is all equal to 2. So here's what I've done. I have taken equation number 4 and plugged that in for x. I have taken equation number 5 and plugged that in for z. So where I had the x, I've now substituted equation 4. Where I had the z, I've now substituted equation number 5. What I now have is an equation that only has y's in it. That's it. That's all there is. It's just y's. Simplify, combine like terms, get y by itself. All right, here we go. In order to do that, let's go ahead, and I need to take care of this too. So that means I'm going to have 3 halves minus y over 2 plus 2y plus y minus 2 is equal to 0. Let's go ahead, I'm sorry, equal to 0, my bad, I apologize, is equal to 2. There we go, is equal to 2. Let's see here, let's, I can combine these guys. That's going to give me 3y, and I can subtract I can add the 2 and subtract the 3 halves. Let's do that. So I'm going to have a minus y over 2 plus 3y. Awesome. So a negative y over 2 plus 3y. That's all going to be equal to 2. Now I'm going to add 2 plus 2, and I'm going to subtract 3 halves, minus 3 halves. Okay, cool. Let me go ahead and clean this up a little bit. I have minus 1/2 y plus 3y is equal. 2 plus 2 would be 4, minus 3 halves. Okay, let's keep going. In order to add fractions, I need a common denominator. So what I'm going to need is I'm going to go ahead and put a 2 in the bottom down here, but that means that this now becomes 8 halves, right? So I have minus 1/2 y plus 3y is equal to 8 halves minus 3 halves, which is going to give me 5 halves. All right, so 5 halves. Okay, so now here's what I got to do. I got to solve for y. These are like terms, right? I can combine these guys. I have a 3y, and I would be subtracting half a y. So 3 minus a half would be 2.5, or 2 halves. Sorry, not 2 halves. Would be 3.5, or 5 halves. 5 halves as a fraction. Let me do this for you. Let's go ahead, right, and just do the what you guys know, right? In order to add or subtract fractions, you need a common denominator. So that's what I'm going to do. I'm going to get a 2 here. If I'm going to put a 2 down here, I have to multiply the top by 2, which means I would have 6 halves. So minus 1/2 y plus 6 halves y is equal to 5 halves. Well, now that I've got fractions, we can go ahead and add these guys together. A negative 1 plus 6 is 5. I keep my common denominator, which is 2. So 5 halves y is equal to 5 halves. Well, in order to get the y by itself, you divide the 5 halves to the other side, and we get y is equal to 1. Because anything divided by itself, of course, is 1. So y is equal to 1. Well, now that we know what y is equal to, it's actually going to be very, very simple to find the rest of it. Here's all you need to do. I know that y is equal to 1. So if I plug a y in here, I can solve for x. If I plug a y in here, I can solve for z. So let's go ahead and do that. X, oh, sorry, get my little marker here. X is going to be equal to, here we go, we're going to plug a 1 in for y. 3 minus 1 would be 2. 2 divided by 2 is also 1. So x also equals 1. And then we're going to go ahead and find z. Well, in order to find z, I need to plug 1 in for y. 1 minus 2 would be a negative 1, and so z is equal to a negative 1. And remember that this represents an ordered triple, so let me go ahead and show you what that is. It, of course, is going to be x, comma, y, comma, z. So 1, comma, 1, comma, negative 1 would be your ordered triple. Okay, here's what we did. Just to recap real quick, because I had a problem where I had 2 equations that only had 2 variables in it, substitution is going to be the fastest way to do it. Elimination will work, but substitution will be faster. Now, how do I know what variable I'm going to solve for? First, I need to find the variable that appeared in all 3 equations. That was the y. Here's where it gets a little tricky. I did not solve equation 1 and equation 2 for y. The reason is because I'm trying to do a substitution. I need to substitute into equation number 3. So actually, I solve equation number 1 for x. That way it's in terms of y. I solve equation number 2 for z. That way it's in terms of y. And what that allows me to do is then do my substitution into equation 3, where now I have something that has all y's in it. Again, I know it's a little tricky, it's kind of complicated. We'll get some more practice as we go through the notes and of course on the homework. Remember, go slow, take your time, number your equations, and make yourself little notes. Make sure you show all your work in case you get lost. You have something to come back to. Guys, head on over to the next page of the notes. We'll try another one and I'll meet you there.